Now that we've talked about how to graph a linear equation, let's talk about how to graph a linear inequality. Just like the one variable inequalities, there are a couple of distinct differences when graphing and solving. To graph a linear inequality, you need to indicate, is it going to be a solid line or a dotted line, just like we had to indicate if it was an open circle or a closed circle. You'll use a solid line when the inequality has an equal to sign underneath, and you'll use a dotted line when the inequality does not have an equal sign underneath. In addition to deciding whether to use a solid or dotted line, you need to shade. You'll either shade on top of the line or below the line. You can pick a point to plug in for X and Y to see if it's a true statement and shade accordingly, or you can let Y alone and decide where to shade based off of whether it's a less than sign or a greater than sign. For the first problem, we need to be able to get Y alone before we can graph. So I have X minus 2Y is less than 4. We're going to subtract X from both sides. Negative 2Y is less than negative X plus 4. Then we'll divide by 2Y. We'll divide by negative 2. And since we divided by a negative, this less than symbol becomes greater than. Negative 1 over negative 2 becomes positive 1/2 X. And then 4 over negative 2 becomes negative 2. Just like equations, we need to identify the slope, 1/2, and the y-intercept, 0, negative 2, before we begin plotting. 0, negative 2 gets plotted. Then the slope tells us to move up 1 and right 1, 2. Do it at least one more time. Before you connect the dots, decide whether you'll use an open or dotted line or a solid line. Because this does not have an equal to symbol, we'll use a dotted or dashed line. To decide where to shade, you can do one of two things. You can pick a point that's not on the line, like for example 0, 0, and plug it in for X and Y. If it makes a true statement, you'll shade that direction. If the statement that it makes is false, such as 5 is greater than 7, you'll shade the opposite direction. If you don't want to pick a point, since Y is by itself and on the left side, you can read the inequality to decide where to shade. Y is greater than. That's a greater than symbol. That means that the shading will happen on top of the line, where the Y's are getting greater than. Let's do it again. You need to solve to get Y by itself first. So I have 2X plus 3Y is less than or equal to 3. We'll need to subtract 2Y from both sides. 2X from both sides. 3Y is less than or equal to negative 2X plus 3. Divide by 3 all the way across. So Y is less than or equal to negative 2/3 X plus 1. Identify your slope and your y-intercept. Slope is negative 2/3. Y-intercept, 0, 1. 0, 1. Put a dot then go down 2 over 1, 2, 3. Down 2, right 1, 2, 3. Because it's an equal to symbol, we're going to use a solid line to connect these dots. Either pick a point not on the line to indicate where shading should happen, or since y is by itself and on the left, I can look and see y is less than, so that means we will shade below the line where the y's are going down. The next problem adds just a little bit of a hiccup. It doesn't have a y value. It says only x is greater than 0. That means that we don't have the ability to find a slope because there's no y value to get by itself. Whenever you see x by itself with no y value, you know that it indicates a vertical or up and down line. This line goes through 0, 0. And it should be dotted because it does not have an equal to symbol. Now for the shading. You can pick a point for x, like 5, which would be over here. Is 5 greater than 0? Yes. So I would shade that direction. Or, since the variable, or x, is all by itself on the left, it says x is greater than. You need to ask yourself which side has the x's getting bigger. That's this side. Let's solve the next one to get y by itself. X minus 2y is greater than negative 2. Subtract x from both sides. Negative 2y is greater than negative x minus 2. Divide by negative 2 all the way across. And remember my silly jingle. Since we divided by a negative, we have to switch the inequality. We have 1/2 x plus 1. The slope is 1/2. The y-intercept is 0, 1. So that's where we're going to begin. 0, 1, put a dot. Up 1 over 2, up 1, right 2. We have a less than symbol without an equal to. So we're going to use a dashed or dotted line. Y is less than, so that means we need to shade where the y's are actually getting smaller or are less than the line. That would be below the line. Two more. We need to get y by itself. Subtract 3x from both sides. Negative 4y less than or equal to negative 3x plus 20. Divide by negative 4. Since we divided both sides by a negative, we need to switch that inequality. So we have 3/4 x minus 5. So our slope is 3/4. Our y-intercept is 0, -5. Down 1, 2, 3, 4, 5, and put a dot. And our slope would go up 3, 1, 2, 3, right 1, 2, 3, 4. 1, 2, 3, right 1, 2, 3, 4. Because there's an equal to symbol, we're going to use a solid line. And it is y is greater than, so we're going to shade on top of the line where the y's are getting bigger. Our last example doesn't have any x's. Or you could say it has 0 x's. Now I can say that because this line is actually a horizontal line with 0 as the slope. And it's going to go straight through 3. So line up your ruler at 3. Whenever y is by itself without without x, you know that it's going to be a horizontal line or left-right line. And we're going to use a dotted line because it didn't have an equal to symbol. And it says that y is less than, so we will shade below.